I'm Mercedes Landazuri.
And I'm Lindsay Neville.
And with our powers combined, we are PlastChicks, the voices of resin.
And we're here today to speak about probably my favorite thing. It's injection molding day.
Injection molding.
Woohoo!
So Lindsay, you have done a lot of injection molding over your career.
Yeah.
So I'm going to put you on the spot here. Quick, name 3 parts that you have injection molded personally.
Okay, a lot of pressure, but dog toys, wire channels, let's see, thermostat covers, and cannulas for medical devices.
Okay, that's 4, so you're showing off now.
I can go more.
I know you can, you overachiever.
It's me. Well, what are 3 parts that you have made colors for that are injection molded?
That are injection molded. Okay, toilet seats.
Important.
Critical. Let's see, phone cases.
Also important.
And cups.
I like those. Those are good ones.
So, Lindsay, since you have done so much injection molding, why don't you explain to us how it works?
Okay, I can do that. So if we take a look here, basically the material is going to go into the hopper. The hopper is going to bring the material into the barrel, which is where the screw resides. The screw is going to melt, mix, and move your material. The barrel is heated. When the screw backs up and builds that shot, the shot is going to be the volume of material you need for your final part. And basically it'll push the material into the mold through the nozzle. Then the material goes in through the sprue, into the runner, into the gate. The gate is the entrance point to the part. The mold's going to hold it closed until that part is cool enough. It'll open up. When it opens up, you're going to have ejection pins are going to come forward, knock that part off the mold. 1, 2, 3, there's your part. Easy as that. Hey, are you paying attention to my lovely description?
Yeah, no, that was great. That was real cool. No, it just got so bright in here that I had to put on these injection molded sunglasses.
Okay, well, if you can show us that, maybe you could show us some other injection molded parts.
Absolutely, I'd be happy to. Let's take a look. Okay, so we got the sunglasses. How about this?
Oh, look at that. I think everybody knows that.
Yeah, look at that. I can't believe it's not nylon. No,
okay.
Yeah, that's a silly joke. But yeah, so this container, both the tub there and the lid themselves, those are both made by injection molding.
Standard household item.
I actually stole these from you. I don't know if you noticed.
I didn't notice.
You offered me a mint, and then I took all of them. So again, both the container and the lid there, which has the living hinge, polypropylene.
Love polypropylene for that.
We've got, one of my personal favorites, like just small things.
I'm impressed it's not filled up.
Yeah. Well, we are in Chicago, so
we're not doing the
a little
Lord.
bit later. No. Maybe. Well, okay. We'll see. This beautiful vase or vase. Look at that beautiful color, right? And you can see right there where the
there's the gate we were talking about.
And then we got to keep ourselves looking sharp, so we got some combs there.
And this actually shows you the sprue with the runner and the gates. So it gives you that idea of that delivery system to the parts.
I feel like I'm on QVC right now. Do I look like I'm on QVC?
You could be on QVC. I'm not 100% sure. But basically, our point here is injection molded parts are everywhere.
Truly, from the toothbrush that we brush our teeth with every morning, to the little button on the wine box that we console ourselves with every night. Injection molded parts are all around us.
Well, you know what? Why don't we go take a look at our social media page and see if anyone has some questions for us?
All right, let's take a look at our socials then. So here is one from Sir Prince-A-Lot. Get it, like 3D prints?
Okay, I know where this is going.
So my friend has a really nice 3D printer, and she said she can make any part she wants.
Fair.
Why would she choose to make it with injection molding instead of just 3D printing it?
Okay, so 3D printing has its merits, but injection molding, it's going to be more cost effective. You can do higher volume, and you can do repetitive, high quality parts, very precise.
Very precise answer
Very
as well. All right, let's take another, shall we?
Yes.
So this one's from Gwyneth Meowtro. I love that.
Hi, Gwyneth.
Dear PlastChicks, I just interviewed for a customer service role with a company that does injection molding.
Good for you.
She gets it. It seemed really interesting, but because the work that they do is proprietary, I wasn't allowed to go onto the manufacturing floor and see what the machines look like or how they work. Can you show me some machines in action?
You know, that's how it always is. You got the proprietary this, the NDA that. It's all very secretive.
Very hush-hush, right?
Very hush.
Or she might have been wearing open-toed shoes.
Can't do that.
Gotta wear the closed toes. Closed toes. Well, we're very close to Wisconsin.
Very. So, Gwyneth Meowtra, we get it. We know you want to see a machine in action. So why don't we go do that?
Yeah, and because we're in our Chicago studio here, I can take us on a little field trip.
We're not going to get Malort. I'm not doing shots at 9 a.m.
The shot glass was just to show the people, apart. No,
I don't fully buy in that, but okay.
Okay. I'm going to take you today, Lindsay, to a very special and magical place. Are you ready?
I'm ready.
All right.
I cannot believe we are here. I am so excited.
I know we get to come on the floor too.
This might be one of my top 5 days.
Well, okay. Well, I know you gave birth 4 times. You have 4 kids, and you got married once.
It's fine. Pick one.
Okay.
Hey, it's great to see you guys. Hi, Mercedes. Good to see you.
Hi, Stephen.
Lindsay, nice seeing you.
Hi, you.
That's it, our guest of honor.
Stephen, we love injection molding.
Yeah.
We love Sumitomo.
Awesome.
I want to see everything in action. Tell us all the details. Give us every little bit of morsel of information.
I would be happy to. So I'll give you kind of a quick overview of everything that you see here right now. So we have one of our training molds that's running here in our 100-ton press. So if you want to come over, we'll kind of start from the very beginnings of the process.
Love it.
Let's do it.
So this is a hopper. This, of course, is a manual hopper where we'd be pouring material in. But as you can see here, this is the resin that now gets kind of gravity fed down into the feed throat area. So in the feed throat area, this is the beginnings of where we start to build up a shot, what's going to end up being our plastic shot into the mold. So right now you're going to see our screws going forward. It's actually injecting at a desired velocity into the mold to make whatever our end user part might be.
So it's mix, moving, and melting?
It is doing all 3 of
MMM.
those.
Look at that.
It's doing all 3 of those things. Now as you can see, the screw is actually recovering, or as it's turning, that screw RPM is actually pushing all of this material forward, getting it into a molten state, so we can just then go ahead and repeat the process.
I love it. So we have some really cool buttons over here.
Yeah.
And we have a lot of numbers. So what are some of the main process settings that
Sure.
you would want to set real basic?
Sure, and that's a great question, because that's really where everything kind of starts, is on this end. So I'll take us to the temperature screen first, because there's a large number of different resins that any one of the manufacturers can use to make whatever the part might be it a medical part, food grade packaging, electrical connector, and anything in between. So there's a desired temperature profile that we have to get this plastic to the perfect state of melt. And then on the injection side, there's a few basic things, right? There's the RPM, or the speed that we want to recover to pull in our next shot. There's the injection velocity, or how fast and at what pressure we need to push that molten plastic into the mold.
You can't just go super fast.
Or super slow. You don't want to go too slow.
We gotta go
either.
right in the sweet spot.
The sweet spot.
That's
Goldilocks.
That's exactly right. And then, of course, there's a setting inside called back pressure. So as we're injecting that molten plastic into the mold, as you can imagine, there's a lot of pressure that's built up during this process. This pressure is going to push back on the screw. So the back pressure is a setting that we can control in the press that allows you to keep that screw in the position, not allowing that plastic pressure to push the screw backwards.
You know, that makes a lot of sense. Let's look at this side of it.
Yeah,
Because
absolutely.
this is where the business end of it really happens, I think.
This is where they make their money.
All right, can I press buttons?
Absolutely.
All right.
You'd be happy to let you press buttons.
Look at me pressing
knows what
buttons.
she's doing.
I do know what I'm doing. All right. I'm gonna even pull the gate. So look at that. We're gonna tell us about this mold and what some of these items are, and especially including the water lines.
Yeah, absolutely. So as I had mentioned before, this is a training mold for us. This is not a production mold. And really the main difference is some of the things that are machined into this tool would not be things that you'd want in a production environment. So we have different runner lengths, we have different thicknesses, the parts are all a little bit different shape from one another, and this is so we can really kind of help educate the students about how they make changes to their process. This system here is very common to the industry. It's called a toggle. The toggle is basically a mechanical mechanism that allows us to move this platen to a closed or to an open state, and then allows us to get a mechanical advantage of locking over and building our tonnage. You had asked a question about this, so in each one of the tools, and this is a very simple setup, I'm sure you've seen things a little bit more complicated in your travels, but this in essence is going to allow us to transfer water, and it's getting plumbed in on the back side of the mold, to go through the metal portions, right? Because we need to be trying to keep these molds at a desired temperature after we've injected our plastic, because then we want to pull all the heat out. We have to cure the part as fast as we can. I won't say as fast as possible because the part can shrink, it can warp, different things can happen.
Things get wild.
There's a perfect recipe here, just like there's a perfect recipe here.
And also, this side is where the parts come out. So all the ejection is in this side of the mold, and we'll pop the parts right out for maximum fun. So I appreciate this. This has been a really great walkthrough, and it's really nice to see what we talk about.
No, these are some great questions, Lindsay. Mercedes, where's Mercedes?
She's doing an interpretive dance to reinforce what she's learned.
Oh, we
It's
gotta
her
see
style.
that.
Go.
Is where it all begins. Screw, it's where the plastic blends. The nozzle injects it in the tool mold. It's where the plastic cools. Hopper is where it all begins. Screw, it's where the plastic blends. Nozzle injects it in the tool molded. Now you're a molding fool.
Well, that was a hoot.
That was so fun. I do love a surprise dance party.
Just an impromptu dance party at an injection molding field trip.
So great.
All the fun things.
So many fun things. But we do have one more of our favorite fun things to do.
Oh, would that be finding somebody really interesting and forcing them to talk to us?
That's exactly it. And great news. Today we have Tony Marcelletta, National Sales Manager of Sumitomo DMAG, here with us.
Tony, welcome.
Hi, thank you.
Thanks so much.
Pleasure to be here. Heard about your dance party. Stephen was telling me about it.
Oh yes, he has quite the moves.
I would maybe even show you at the Christmas party.
Yeah.
Maybe not.
Well, it is injection molding related, so.
Oh, okay. Keep it professional.
So, Tony, I heard that you don't actually come from an injection molding background in terms of your education. You actually studied computer engineering, is that right?
Yeah, I was electrical engineer, computer engineer, going back many years ago, about 30, and had to do an internship, had an opportunity to come to work for an injection molding manufacturer, and here I am 30 years later, still in the plastics industry.
Mm-hmm. And what was it like making that leap? What are the similarities between the two, or how are they interconnected?
Well, if you look at it, especially now, the controls are so vital. They're really the brains of the operation. I like to say, mechanically, machines arguably haven't changed dramatically like the controls have. We went from open loop technology 30 years ago to now AI technology. It's just really pushing the envelope, and much like cars have changed. You girls are probably too young to remember like the 3 pedals and where you had to push a clutch and everything.
Oh, we will very proudly tell you.
We both drive stick.
Oh, that's so awesome, so awesome. We'll have to talk later, but you go now and you look at all the sensors and all the backup cameras and auto driving cars. It's same things really happen with the molding machine.
And technology is kind of always evolving with equipment, with software, and then on top of that you have all these customers or potential customers with a wide variety of what they could be molding and what their requirements are. How do you at Sumitomo DMAG bring that together and decide what to showcase to them? Like how do you make those decisions?
Sure. Yeah, it's really a challenge we have and our sales force has, and we're really consultants in that manner. We have to not only understand our customers' needs, but trends in the industry. You look at a lot of the new material developments. They're around post-consumer recycled goods.
Right.
Those really have a lot of challenges for our molders. Batch to batch, lot to lot variation in material density and material viscosity. So we have to suggest a control that could adapt for that. Some algorithms in the control that help them out. We hear over and over again the lack of skilled labor. A lot of my customers, they're willing to grow, the work's there for them to grow, and they just can't find operators, they can't find setup people. So we have to make innovations in the control that make it easy for them to bring somebody on board, help them train them, and with very little, if any, plastics experience.
Yeah.
And just, understanding the end product too. Is it a single-use water bottle cap that they're making, or is it maybe a surgical device, or maybe an implantable medical device? Do you take a top fuel dragster to the grocery store? Probably not. Same thing with the molding machine.
Slight overkill.
Yeah, a little bit. A few speeding tickets.
So, like you said, you've been here quite a while. Over those years, do you have any projects that really spoke to you, appealed to you personally?
Wow, 30 years worth. It's really, really hard to say just one. There's been a lot, and my passion, like I said, is automotives. I love seeing some of the sexy new, developmental type projects we've been involved with. LED lighting has been one. You look at the cockpit of a car now; it's completely different than what it was 30 years ago. Just really cool innovation, and it's all plastic. But then you can't forget the pandemic we just went through. The aging demographic we have. A lot of diagnostic equipment, a lot of drug delivery devices, and just couldn't be possible without plastics and without injection molding, and then things that you just see every day. I think I once about got kicked out of a grocery store for spending 2 hours in the dairy aisle, handling every product on the shelf.
I love that for you.
So yeah, I mean, just some great innovation even in simple goods, like a food grade container, making it compostable, making it recyclable. I think it's to a point now. My wife even walks into the grocery store, looks over, she's like, "That's injection molded," puts it on the shelf.
Yes!
Team injection molding.
Oh, yes. I love that. Well, Tony, thank you so much for joining us today. We really appreciate it.
It's my pleasure to be here. Thank you.
Well, that's all the time we have for today, folks. Please send us your questions, comments, and concerns, and they will be addressed in a timely manner by our QC department.